In this video, we're going to talk about the three subatomic particles. As you know, atoms are made up of protons, neutrons, and electrons. A proton has a positive charge, an electron has an equal but negative charge, and a neutron has zero charge. Comparing their masses, you can see that protons and neutrons are about the same. Notice that the 10 to the negative 24th on these means that it is a very small mass in grams. The electron is even smaller because it's times 10 to the negative 28th. So that we don't have to deal with these powers of 10, scientists have given the proton and the neutron a mass of 1 AMU, where AMU stands for atomic mass unit, or AMU. So relatively, while a proton and a neutron have a AMU, or mass of 1 AMU, the electron, since it's so much smaller, is essentially going to be 0. So when we're looking at the overall mass of an atom, we only look at the protons and the neutrons. And we're going to ignore the electrons because they're about 1,800 times less than the protons and neutrons. Each of you got a periodic table, and on this we have all of the elements, and you see a lot of numbers associated with these elements. What we'll do here is see what each of these numbers mean. First of all, we have the atomic number, which is the big number underneath the symbol on your periodic table. This puts them in order, 1 through 110 on your sheet, but it is also the number of protons in each of the atom. So hydrogen, with atomic number 1, is going to have 1 proton, whereas zinc, with atomic number 30, is going to have 30 protons. This is what separates different elements from each other, their number of protons. Next we have the atomic mass. This is going to be the number at the top. This is the combination of the protons and neutrons. We said each of these has a mass of 1 AMU. So when we add all these up, we get a number. Now we'll be dealing with whole numbers for the most part because we'll be looking at single atoms. But when you take into account all of the atoms that exist for particular elements, you'll see that they end up with a decimal. And this is called the weighted average mass, and we'll get into why this occurs a little later on. The electrons typically balance out the protons, since these have a positive charge and these have a negative. That means that the atom overall will be neutral. That occurs only when the protons equals the electrons. So for a neutral atom of carbon with an atomic number of 6, it would have 6 protons and 6 electrons. A neutral atom of calcium would have 20 protons and 20 electrons. However, we can have a situation where the number of electrons does not equal the protons, and in that case we have formed what's called an ion, or a charged atom. Now this charge will just be the difference between the electrons and the protons. When we have a positive ion, it means that we have lost electrons, so those negative charges go away, leaving us with excess protons. So the atom overall will have more positive charges, so it's a positive ion. On the other hand, if we gain more electrons, we have more negative charges, so we have formed a negative ion. Notice that it's only the electrons that move. The protons aren't going to go anywhere. If it does, and then you change the number of protons, you now have a completely different element. So ions, even though they have a different number of electrons, will still be the same element because the protons will be the same. So we'll be dealing with this generic atomic symbol. In the middle, you'll have the symbol for your element. So each of the elements, as you can see, has a 1 or 2 letter designation. Some of them are the first letter of the name. Others are from other names that have been changed or still used today. So that will go in the middle. In the top left, you're going to have your atomic mass. This is the sum of the protons and the neutrons. In the bottom left, you'll have the atomic number, which is just the number of protons. So just referencing back to your periodic table, here's your mass. For our purposes, we're going to use whole numbers here. Then you have your atomic number, which is your number of protons only. If there is a charge, meaning a difference between the protons and electrons, that charge will go here. So you'll see things like +1 or -2. That will tell you whether it's a positive ion or negative ion and what the difference in protons and electrons is. If there is no number here, you can only assume that it's 0 and that it's a neutral atom. So we're going to practice answering each of these questions based upon the symbol given. So we want to know if this is an atom or an ion. There's no charge listed here, so it's not an ion, meaning that this is an atom, and it happens to be an atom of carbon. You find C on your periodic table, and that's carbon. The atomic number is the smaller number at the bottom, which here is 6. The atomic number always equals the number of protons. Always. So this is 6 also. The atomic mass is up in the left-hand corner. This will be bigger or equal to the atomic number in the case of hydrogen. So here our atomic mass is 12. Now, number of neutrons. This isn't listed directly on the table. However, we said that the mass equals protons plus neutrons. So algebraically, to find the number of neutrons, we would subtract the protons from the mass. So if we have 12 total mass protons and neutrons, and we subtract off our 6 protons, we're left with 6 neutrons. So 12, our mass, equals 6 protons plus 6 neutrons. We already said that this is a neutral atom because there's no charge listed here, so this is 0. So to get our number of electrons, there is no charge here, so we know it's neutral, and protons equals electrons, so therefore there are 6 electrons as well. So if you want to look for a formula to describe that, you would do protons minus electrons equals charge. So in this case, 6 protons minus 6 electrons equals 0. Here we have an atom of oxygen, atomic number 8. It's not an ion because there's no charge listed. We said the atomic number is 8. Therefore, it also has 8 protons. The atomic mass is number 16. To get the neutrons, we take the mass and subtract the protons, so we get 8 again. There's no charge listed, so it's 0. And since there's no charge, electrons equals protons. Very simple. Very much like the last one. Now you'll see that we have something different. In this case, we have a +1 up here. This means we have a net +1 charge, so instantly we know that this is an ion, and we may as well fill out this +1 charge down here. Atomic number, still in the same place, 19, therefore still 19 protons. Atom or ion does not change this relationship. These are always the same. Atomic mass is up here, 39. Now, in the previous 2 examples, our protons have equaled our neutrons, but you'll see as we go down the periodic table, getting heavier and heavier, we're going to need more neutrons to balance out the protons, and we'll talk about that, why that occurs a little later on. So to get the neutrons, once again, we have mass minus protons, so neutrons equals mass minus protons, just reformatting our algebraic equation from earlier. So 39 minus 29 gives you 20. Now, charge. If we have a +1 charge, that does not mean we gained an electron or that we gained a proton. Remember, to form an ion, we have to lose electrons or gain electrons. In this case, an extra +1 charge means that we lost an electron somewhere, so we have an additional +1 charge left over. So if we have lost one electron, we now have 18 instead of the 19. So going back to our equation from earlier, P minus E equals charge. If you wanted to solve for the number of electrons, you would move electrons over to the other side, move the charge over here, and get that the protons minus charge equals electrons, or 18 minus +1 gives you +1. A +1, or positive charge in general, positive charge means lose electrons. Positive charge, you lose electrons. Now here we have a -3, so it's an ion. Charge is -3, so this is an ion of phosphorus, atomic number 15. 15 is here, so still 15 protons. Our mass of 31. To get neutrons, we do mass minus protons, so we get 16. Now, a -3 charge means we have an additional 3 electrons. So instead of having 15 like a neutral atom would, we have 3 additional. 15 plus 3 gives us 18. So from our formula, electrons equals protons minus charge. We would have 15 minus -3. When you subtract that -3, it becomes a positive and you get 18. So a negative charge means gaining electrons. Negative charge, gain electrons. Here we're going to do it backwards. I give you the information, you'd have to make the symbol. So we want a charge of +2. We know that goes in the top right. It has 20 protons. That's the same as the atomic number. So that's going to go in the lower left-hand corner. Has 22 neutrons. We need to know that because we take the protons plus the neutrons. That gives us our mass, 42. Now the only thing we're missing here is the symbol. But how do we use this information to get the symbol? We look at the protons. Anytime an atom has 20 protons, it is calcium, atomic number 20. And the symbol for calcium is Ca. That's the end of subatomic particles, and we'll talk about isotopes next.